Welcome to Root Research, where we decode science in plain language so you can grasp the ideas that are shaping our future. Today we're talking about a brand new way to store digital data in DNA, discovered by Bichlien H. Nguyen and collaborators from Microsoft Research and the University of Washington. A development that could flip the data storage world on its head and help solve our planet's growing data problem. Let's jump in. What if your smartphone's entire memory fit in something smaller than a grain of rice? We humans generate so much digital data, photos, videos, messages, even videos of cats, that the amount produced each year is exploding way faster than the tech we use to store it. Traditional hard drives and magnetic tapes eventually wear out, cost energy, and take up huge physical space. DNA, on the other hand, naturally stores information in every living cell on Earth, and it does it with amazing density and longevity. But here's the twist. Even though DNA is the best information storage system nature invented, writing data into DNA fast enough and efficiently enough for real-world use has been a huge bottleneck. That's where Nguyen and the team come in. What did Nguyen and colleagues notice? They saw this problem. Current DNA data storage technology was too slow and too bulky to be useful outside a lab. The core issue was writing, turning digital bits, zeros and ones, into actual DNA molecules. Traditional methods just couldn't jam enough writing spots into a tiny space without chemical interference between them. So Nguyen's team created a nanoscale electrode array. Think of it like a super tiny pen that can write DNA sequences in millions of tiny wells on a chip. By packing these writing spots millions per square centimeter and controlling acid production electrochemically so nearby spots don't interfere, they dramatically upped the density of DNA writing. Why does that matter in real life? Imagine a world where massive cloud storage data centers, those huge buildings with endless rows of servers, Nguyen, could shrink into something as small as a book. Today's data centers take power, cooling, and materials, contributing to energy use that's predicted to skyrocket if we keep storing data the same way. DNA could change all of this. In one real-world scenario, suppose a company needs to archive decades of historical video footage, things that aren't accessed frequently but must be kept. Storing that on current drives might require miles of equipment and tens of thousands of watts of power. With DNA storage, thanks to what Nguyen's team showed, those same archives could be reduced to a tiny DNA library that doesn't need constant electricity and could last for centuries. How does the DNA writing actually work? Put simply, digital bits get translated into DNA base sequences, A, C, G, T. Then the team's chip uses electrodes to generate acid in nanoscale wells. The acid removes chemical blocking caps so the next DNA base can attach. The genius here, the wells and electrodes are spaced so acid from one spot doesn't leak into another. That's how they packed so many writing spots close together without messing up the sequences. They tested this by encoding a message into 4 unique DNA strands of about 100 bases each, and they were read back correctly. The team demonstrated that even though the error rate is still higher than commercial DNA synthesizers, the data was decoded without mistakes. Why does this tech feel like sci-fi? DNA storage is beautiful because it mirrors what nature has perfected over billions of years. This isn't genetic engineering of living organisms. It's synthetic chemistry creating DNA strands only as data carriers. And DNA stability means data could be retrievable long after modern magnetic storage fails. Think about it this way. We currently take periodic backups because disks fail in decades, but DNA could hold data for hundreds to thousands of years without power. Museums, historical archives, even personal lifetime memories, all safely tucked away in tiny DNA libraries. What's the big takeaway? Nguyen and the team moved DNA data storage a giant step closer to reality by solving a core technical hurdle: how to write data into DNA more densely and at much higher throughput than before. They proved that you can build chips with millions of DNA writing spots that don't interfere with each other, and they successfully wrote and read messages from DNA created with this method. This doesn't mean your next USB stick will be DNA yet, but it means the foundation for practical, scalable DNA data storage is real and could transform how we think about long-term, ultra-dense, energy-efficient information storage. Thank you to Bichlien H. Nguyen and collaborators for pushing the frontier of data storage technology. If you like what we do, subscribe and write a comment. Let's unpack more science together.